All right, so in our last unit, we simplified rational expressions, we solved rational equations, and now we are going to graph rational functions. Let's see. All right, your parent function for rationals is y equals 1 over x. I want you to remember that f of x is just another way to say y. So when you see f of x, that just means y. Sometimes it will say f of x or g of x or even h of x, but they all mean just y. Before we talk about the x-intercept and the y-intercept, I want to talk about the asymptotes. Rational functions have both vertical and horizontal asymptotes. So here's your vertical asymptote at x equals 0. I want you to draw it in too, okay? Draw in your vertical asymptote at x equals 0. Notice it goes between the branches. And then your horizontal asymptote also goes between the branches at y equals 0 for your parent function. Okay? You will never cross your vertical asymptote. There are rational functions that cross the horizontal asymptote. The vertical asymptote is an undefined value. You can never be that. The horizontal asymptote really just defines the end behavior of the function. So whenever you have a horizontal asymptote, instead of the y going to infinity or negative infinity, it's just going to go to that number. All right, so since we have asymptotes on the axes, there is no x-intercept or y-intercept. So your domain starts all the way on the left at negative infinity. And it continues, you'll see this piece, it continues all the way over here, and is getting closer and closer to your asymptote at 0, but it will never touch it. So it goes from negative infinity to 0 with a parentheses to say not including 0. But then there's another piece over here, right? So there's two pieces to this function. So this piece is negative infinity to 0, and then the u is union, means this and this. The other piece starts right after 0, and it goes to infinity. Okay, so your domain comes in two pieces. Same thing for your range. Your range is going to start at negative infinity. It's going to go up to 0, but we have to leave 0 out because of the asymptote, and then it's going to go from 0 to infinity. So it's the same domain and range for the parent function. It does change, though, when we transform the function. So they won't always be the same. All right, do remember that the end behavior will always match your horizontal asymptote. Okay, so x can still go to negative infinity and positive infinity. But in both cases, as x goes to negative infinity, the y is going to be approaching 0. It's getting closer and closer to 0. And same thing on the right side. As x goes to positive infinity, the y is approaching 0. All right, and those are just describing your parent function. So please make sure you have all those down for your parent function. And then we're going to talk about the transformations and how to graph a transform function. All right, we have the same a and h and k that we had in all of our other functions before. I think that the one that we've done the most has been the parabola. We did y equals a times x minus h squared plus k. The a was a vertical stretch or a reflection or a compression. I'm running out of space. The H was a horizontal shift left and right, and the K is a vertical shift up and down. We didn't do a B before, and honestly, we're not going to really be using B now either, but since it's in the formula, we're going to describe what that is. So the B is a horizontal stretch or compression, or reflection. We just don't cover that in this course. Okay, so then we said the H is going to shift you left and right. The K is going to shift you up and down. Just like, remember how the H, when it says -5, it actually shifts you right 5? It happens inversely. Anything that happens to the X happens inversely. So also the B value, which, like I said, we're not going to be using any B values, but just like for the future, so you know, the B value also happens inversely. So if the B was like a 0.5, it would actually stretch you horizontally by 2. Okay, but we're not going to have those. All right, so let's look at this one here. What are the transformations? Here's the easiest one. The +4 shifts you which way? That's right, Nahar. Thank you. Up 4. All right, the -1 is moving your X, so it's happening inversely. So instead of going left, it goes which way? Right? So up 4, right 1. The A value is -2, so that does 2 different things. What does the negative do? The negative is going to reflect you. So vertical reflect. And then the 2 does what? Stretch or compress? It's going to stretch you. So vertical stretch of 2. Okay. I think we will want to look at this in our graphing calculator real quick, but we actually can graph a lot of it even without the graphing calculator. But let's just look at the calculator. So when we put this in the calculator, if you have more than one term in your numerator or denominator, you will need parentheses to hold it together. So make sure you put those parentheses on your paper and then you type them on your calculator. Just in case the IB students did something with your calculator, you can clear your memory with second plus 7, 1, 2. Anybody want to hear it again? To clear your memory, it's second plus 7, 1, 2. If you don't have a calculator, please get a calculator. Go to your y equals, and we're going to put in -2 divided by parentheses x minus 1, close parentheses, plus 4, and then graph it. And you should see 2 branches, but of course they're going to be transformed a little bit. Good morning. Okay, so that's what it looks like. All right, so you have your asymptotes here and here, but we need to know exactly where they are. So let's go back and look at the transformations. No, that's your seat. But you're not seeing it, you're taking a quiz. So your transformations are that we shift right 1. So this one goes right 1. So it was at x equals 0, but now it's at x equals 1. This one is up 4. So it starts at 0 and it goes up 4. So it's like right here. All right, now, because of the -2, instead of having your branches here and here, they do reflect down here and up here. We can get some points for your branches from your graphing calculator. So we'll do second table. And we need some points that are before and after 1, because we had asymptote at x equals 1. So I'm going to go up to get some more points. Okay? So for example, I can make 2 on each branch. So I could use -1, 5, and 0, 6. -1, 5, and 0, 6. And then I can also graph 2, 2, and 3, 3. 2, 2, and 3, 3. So I just graphed the points that I saw, like that. And then I'm going to sketch the branches in around those. So I'm going to sketch like this. Oh, does anybody want some more help with drawing the graph? Anybody want to see how to get your points or your asymptotes? Okay. All right, so your vertical asymptote is right here at x equals 1. Your horizontal is right here at y equals 4. And we got those from the transformations. Vertical is always going to be x equals, horizontal is always going to be y equals. Your domain and range will have 2 pieces. I'm going to do the domain with you, and then I'm going to ask you to try the range. Go to airplane mode. There should be no. Okay, so your domain is going to start over here on the left at -infinity, and it goes to 1. And then right after 1, we start up again and go to +infinity. So do your range, please. Your range should have started down here at -infinity, and then it goes up to your horizontal asymptote at 4. So -infinity to 4. Then you start again right after 4, and you go up to infinity. All right, for your x-intercept, it looks like we can see it because we already marked it here at 0, 6. You can always get your x-intercept from your table of values. So let's look at your calculator real quick. See 0, 6 is right there on your table of values. To find your y-intercept, it doesn't look like it's an integer, but you can find your y-intercept by making x 0. Okay, so we would have -2 over 0 minus 1 plus 4. That's not working for me, actually. Why is that not working? Oh yeah, I see it is working. I just marked it wrong here. All right, -2, 0 minus 1 plus 4. That gives me 2 plus... No, it's not working for me because that's 6, and that's definitely not the right answer. It's the oh, that's the y-intercept. Sorry. The y-intercept is 0, 6. It's the x-intercept I need to find. I got it. Okay. The x-intercept, we make the y 0. So that's going to be more work. I think I need more space for that. Okay. So I have 0 equals -2 over x minus 1 plus 4. First thing I'm going to do is subtract the 4. And so I have -4 equals -2 over x minus 1. Oh, you can't see that. Then I'm going to multiply both sides by x minus 1 to get it out of the denominator. X minus 1. That's going to distribute to the x minus 1 to make -4x plus 4 equals 2. And then I'm going to solve it for x. Subtract the 4. -4x equals -2, and then divide it. I'm still not liking this answer. I'm getting x equals 1/2. Let's see what I'm doing wrong here. Hold on. I'm going to pause the video so I can think it through. All right, so I'm not seeing my mistake there, so what I'm going to do is go back and find it on the calculator. So go to your graph, right there. And you can see that your x-intercept is right here. So you can see it should be like about 1.6. We're going to calculate the 0. So we're going to do second trace. And we want to find the 0 of the function, so that's 2. So you're going to press 2. Now notice that it's on this branch over here, and we want it to be on this branch over here. So I'm going to use, let's see, I feel like I used the down arrow or the up arrow to hop over there. This is not my day. I might need to phone a friend. Okay. Yeah, that's not working for me. I need to get over to this one here. I wonder if I just I just held that one down and it worked. Okay. So I held down the right arrow and I got over here. You need to be on the right branch. Raise your hand if you need help getting to the right branch of your graph. Does anybody want help with that? Katie, make sure you're graphing it. Okay, so we're on the right branch. So now we need to be to the left of the 0, which would be down here. So use your left arrow to get to the left of the 0. Oops. There we go. Press enter one time. Then use your arrow to get to the right of the 0. Press enter one time. And then get close to the 0 for guess. And press enter one time. Okay, so I'm getting 1.5, which is what I kind of expected it to be, like 1.5 or 1.6. I don't know why algebraically it was not working out for me today. We will come back to this because it definitely should work both ways. But anyway, we got 1.5. So it was 1.5, comma 0. And then your end behavior, you still have x going to positive infinity and x going to negative infinity. But remember, your end behavior will always be your horizontal asymptote. So because that's at 4, that's what y goes to. Y goes to 4 on both the left and on the right. This one's the left, this one's on the right. All right. Notice that this one is not written in the same pattern as the other one. So because you can't describe it with this pattern, we need a different way to graph it. When you have your rational function in this format, then there are some rules for finding your asymptotes. For your horizontal asymptote, it's going to be y equals 0 anytime the degree of the bottom is bigger than the degree on the top. So this says degree on the top is smaller. So this would say, I'm going to say top is smaller. No, I'm going to say bottom is bigger. Bottom, bigger. And that, I'm talking about the degree, which is the largest exponent. When the degrees are the same, degrees same, then we have this fraction right here. We'll get to that in a second. And then this one is if the top is bigger. If the top is bigger, there's no horizontal asymptote. All right, so when the bottom is a bigger degree, the horizontal asymptote will just be y equals 0. When the degrees are the same, it's going to be the ratio of the lead coefficients, this A over this C. And then when the top is bigger, there is no horizontal asymptote. It can be confusing because of all the different variables that they use. The vertical asymptote are just the zeros of the denominator, so you set your denominator equal to 0. To find the y-intercepts, you make x 0. To find the x-intercepts, you make y 0. And of course, we'll have your calculator to assist you. Okay, so for this one, what is the degree of the top? Your biggest exponent, what is it? You don't see any exponents, right? But what could you put on the x? 1. So the degree is 1. On the bottom, what's the degree? Biggest exponent. It's also 1, right? This is x to the 1. Because the degree is the same, then we're going to take the ratio of the lead coefficients. Is this number over this number. Hi, Aya. Do you know where you sit?
Yeah.
3 over 1, which just becomes 3. Okay, your horizontal asymptote is the ratio of your lead coefficients. So that goes here. Your vertical asymptote, you set your denominator equal to 0. So for this one, I'm going to figure out where I'm going to write it here. I'm going to write x minus 4 equals 0, and then I solve it. All right, let's graph those. Let's graph x equals 4. And y equals 3. All right, then what I would like you to do is put this in your calculator. You will need parentheses to keep your numerator together and parentheses to keep your denominator together. Okay. Y equals, clear what's in there. Parentheses for your numerator. 3x minus 6. Close parentheses, divided, parentheses for your denominator. You can put 1x minus 4, or you can just put x minus 4. And then we're going to look at the graph. All right, so it still has 2 branches. It's just not like a direct transformation of the parent function. We are going to still get points, and what we need are points to the left and the right of the vertical asymptote. So I need to have points before 4, and I need to have points after 4. The first time I did this, I didn't write down my table of values, but I think I'll do it this time. All right, I need points before 4. Notice 4 says error because that's where your asymptote is. So on my paper to the left of my graph, I'm going to make a table of values, and I'm going to copy down 2, 0, and 3, negative 3. And then after the 4, I'm going to copy 5, 9, and 6, 6. And now I'm going to put these on the graph. 2, 0, 3, negative 3, 5, 9, and 6, 6. And then you just want to sketch the branches in between. Remember, the branches will get close to the asymptotes, but in this case they are still not crossing either of the asymptotes. Like that. All right, once you have your graph complete, I want you to try to finish the domain range, x-intercept, y-intercept, and end behavior. Okay, so your domain is going to be everything except for your vertical asymptote at 4. So it should be negative infinity to 4, and then 4 to infinity. And that's how we leave out the 4. Your range is everything except for 3, and so it's negative infinity to 3 and 3 to infinity. I can see my x-intercept pretty clearly here, so that's good news. My x-intercept is right here at 2, 0. And then to find my y-intercept, I can go back to my table of values. And it's 0, 1.5. For your end behavior, I don't care if you do the right side first or you do the left side first. Just make sure you have x going to positive infinity and also x going to negative infinity. And in both cases, y is going to what number? 3, good. Your horizontal asymptote. So your horizontal asymptote is your end behavior. It's like not a coincidence, that's exactly what it is. All right, I'm going to help you guys get the asymptotes for this last one, and then I'm going to ask you to graph it on your calculator, and then finish the analysis. So your vertical asymptote is going to be dependent on the zeros of your denominator. So I have x squared minus 9 equals 0. How do I solve that? I could factor it, right? Because it's difference of squares. And so this would be a minus plus pattern. What number goes there? It is 3, yeah. Because 3 is the square root of 9. And so the minus 3 and the plus 3, when you multiply them, it gives you the negative 9. All right, so then you set each factor equal to 0, so we're actually going to have 2 vertical asymptotes. And when you graph this on your calculator, you'll see how that looks. This one is going to give me x equals 3, and this one's going to give me x equals negative 3. So there are 2 of them. Okay, your horizontal asymptote depends on the degree of the numerator and denominator. The degree of the numerator is 1 because that's your biggest exponent. What's the degree of the denominator? It is 2, yeah. The degree of the denominator is 2 because that's your biggest exponent. So then if we go to the chart at the top, it says when the bottom is bigger, good morning, when the bottom is bigger, your horizontal asymptote is y equals 0. Respond, please. Okay. So those are your asymptotes. I would like you now to graph on your calculator, get a table of values, graph, make a graph, and then analyze your graph here. Okay, so I need to graph this on my calculator. Hopefully you're ahead of me on this. I'm going to press the y equals, clear out what's in there, and I need 4x. You could put parentheses on the 4x if you want, but it's just one term, so it's not a big deal if you don't. And then on the bottom, I do need parentheses around x squared minus 9. All right, and then take a look at this graph. See how it has 3 pieces? And the middle piece actually crosses your horizontal asymptote. You are allowed to cross the horizontal asymptote, but never ever the vertical asymptote. So we're going to need points on each of these branches. So when you go to your table, we're actually going to need at least 6 points. I'm going to say we'll probably use even more. All right, so I'm going to need some points before my asymptote at negative 3, so I'm going to go up here and get some points. None of them are that nice, and I'm just going to have to round them. So on my XY table on the left, you can choose any points to the left of negative 3. I'm just going to choose negative 5 and negative 4. So I'm going to copy negative 5, negative 1.25, and I'm going to copy negative 4. And I'm just going to round that to negative 2.3. Then in the middle, I'm going to take these 3 points right in the middle. Negative 1.5, 0, 0, and 1 negative 0.5. Negative 1.5, 0, 0, and 1 negative 0.5. And then I need some points to the right of my asymptote at x equals 3, so I'm going to scroll down, and I'm going to take those two. I'm going to round that to 4, 2.3, and 5, 1.25. All right, so if you have your table of values already, that's great. If you do not have your table of values, you may use mine. Here, I'm going to graph those points. -5, -1.25, -4, -2.3, and then -1.5, 0, 0, 1, -0.5, 4, 2.3, oops, up here, and then 5, 1.25. And then just take another peek at the shape of the graph just to make sure you're getting the right shape when you graph it in. So looking at your graph here, you should have this shape, and this shape. And then sketch it in. All right, I want you to notice this time your domain has 3 pieces to it. 1, 2, 3. So my domain starts -infinity and it goes to -3. Then from -3 to 3. And then 3 to infinity. So 3 pieces in your domain. Your range, however, has only 1 piece, and I'm going to explain why. Just a second. I want to make sure you have your domain. So even though we have a horizontal asymptote, because we cross that horizontal asymptote, we don't leave it out. So your range starts at the bottom here, and it continues all the way to the top. If the y value is included anywhere, you have to include it in your range. So this range is just -infinity to infinity. Even though we had a horizontal asymptote, we crossed the horizontal asymptote, so we didn't leave it out. All right, and then our x-intercept and our y-intercept is the same point. Do you guys see where we cross the x and y axes? Right here in the middle? All right, so M behavior as x goes to infinity. Notice we're still approaching our horizontal asymptote at 0. And as x goes to, sorry, that was -infinity. As x goes to positive infinity, we're still approaching our horizontal asymptote at 0. So even though there's this extra piece in the middle, the horizontal asymptote still defines your M behavior.